And what's up, guys? Welcome back. This is the key for the momentum rankings and energy intro that we did last week. So this first one, we had to rank on the change in momentum. So what you've got to do is compare the before and after here for all of these. So one thing to notice is that change in momentum equals the momentum, we'll say, let's see, before minus, whoa, oops, that didn't work. Let's say momentum before minus momentum after. So for all of these, like for A, the momentum after is mass times velocity. So after has a momentum of 0, minus the momentum of before is 10 times 4. So 0 minus 40 equals negative 40. And then for B and C, D, E, F, you would go through, and for all of them, so B through F, it equals negative 40 for all of them. So your ranking is that these would be all the same. So they all have the same change in momentum. So if you can do the math behind that, which is just, again, mass times velocity, momentum equals mass times velocity. If you can do that, you can calculate the momentum before and momentum after. Oops, I typed that backwards. Sorry about that. Momentum after minus momentum before. So if you can do that calculation, then these become pretty straightforward, and you just have to subtract after minus before to see what the change was. So those were ranked all the same. Now here we're ranking them on change in momentum, but we have different information. So we know the force on them. So in order to do this one with momentum, the change in momentum equals the impulse. So that's a key term that we've got to know about momentum. And impulse is force times the time. In this situation, all of them are pushed for 10 seconds. So because time is the same, the only thing that's left to, if this is constant, the only thing that's going to affect the impulse is the force. The force is indicative, meaning it's telling us of the change in momentum or the impulse. So what we can do is ranking them based on the force tells, oops, let me move this up, tells us the change in momentum. So then if I'm ranking them based on force, A is going to equal F, and those are going to be greater than, B is going to be equal to D, and those will be greater than C equals E. So they're force times time, and because time is all the same, I can just rank them based on the force. Or I could have said 100 times 10 and 75 times 10, but that seems more work. That's unnecessary. So here we've got, we want to rank them in terms of impulse from most positive to most negative that create the change in velocity. So all cars have the same mass. So what we can look at here for change in momentum is the change in velocity. So here, change in velocity is going to relate to the change in momentum. So the greater velocity change, then the greater momentum change. So here with A, so we want to do the change in velocity is going to be equal to the velocity after minus the velocity before. Just like we had similar to that first one with momentum, we looked at after versus before. So for A, it goes from positive 20, started at 10. So for A, it's going to be 20 minus 10, which equals 10. For B, is going to be 0 minus 10. So that is equal to a negative 10. For C, it's going to be negative 10 minus positive 10, which equals negative 20. D is going to be positive 20 minus a positive 20, so 0. E is going to be positive 20 minus positive 30, so 20 minus 30 gives us a negative 10. Oops. Negative 10. And F is going to give us negative 20 minus a negative 10, or negative 20 plus 10. So F is going to be negative 10. So then if I'm ranking those, I just look at these values. So A is the greatest, it's the only positive one. And then that's greater than D at 0. And then that's greater than B, which is equal to E, which is equal to F. And those are greater than C, which is the most negative. So there's those rankings. And then we had a couple energy basics. So true about the total amount of energy in any system is that it stays the same. And then energy isn't gained or lost, just changes forms. And determine the energy transformation in these. So a firecracker is chemical potential energy. We can just say chemical, well, we can say chemical potential energy gets converted to, let's say, sound. Right? It's really loud. You could say light or heat or something like that. A bicycle, so this one was interesting because you pedal the bicycle. So your kinetic energy moves the bike. So a great answer would say kinetic energy to kinetic energy, which some kids were uncomfortable saying because it's the same type of energy, but it certainly can be that. And then a battery. So battery is chemical potential energy, and that gets converted into electrical energy. Other answers for these would be acceptable, but those were the most common and probably the most expected ones.